Fasten your seatbelts, everyone, because we're going up. And this could prove to be one scary flight for many of you. But we have a major escape route right out the back if you feel like leaving before the flight's over. Hello everyone, Steiner here. Welcome to Controversy Central, where we take on controversies that really matter. In just a few moments, we'll be looking over both the globe and the flat plane to find out if we can begin to see the Earth take on its actual shape. I don't mean to say that we'll be able to look out the windows of the airplane to make that determination, nor do I mean that by jumping out of the airplane we'll be able to make that calculation either. Rather, I mean that we will head to the Arctic, both temperate zones, and the tropics to discover the actual shape of the Earth. So feel free to come along for the flight. You may be surprised by what you see. But unfortunately it won't be in this plane. It looks like some of the passengers are leaving mid-flight as we speak. But I sure hope that most of you will stay with me. Together, we can observe what happens as we plot locations and distances on my two models of the Earth. In my last video, I plotted distances between three pairs of cities on both a globe and a flat Earth model and showed that both models were accurate for north-south distances. I will now do the same for east-west distances, using the very same methodology. This means that each pair of locations will be as close to 2,088 miles apart as reasonably possible. I have even used small dots of blue mounting putty at any place on the globe where the population centers I needed to use were too small to be printed on the globe model. If you are interested in various details that I will not repeat here, such as how I arrived at 880 miles per inch on my flat Earth model, or 500 miles per inch on my globe model, that information can be viewed by watching my last video called Epic Battle Globe vs. Flat Earth Round 1. But I will show what I expect to see when I use my specially marked string to make my measurements on the globe. I took the longest and shortest of the distances that I found between my paired population centers to get approximately 2,100 miles. Here's how that is indicated on my string. Since 1 inch represents 500 miles, we need 2,100 divided by 500, and that gives us 4.2 inches on the string. I've marked out 1 inch segments in red, and immediately after the first 4 1 inch segments, divided that fifth 1 inch segment into 5 2/10 of an inch segments in black. Starting from the northernmost city in each of my pairs, I expect the southernmost city to be reasonably close to the first black mark in the fifth 1 inch segment. And now we begin. Starting north of the Arctic Circle and ending in Australia, I will compare how the globe and flat Earth models stack up beside each other. Will they both be accurate? Or will either one or both be shown to be useless as true representations of the surface of the Earth? Let's find out. We will now see what happens as we chart the east-west distances. I've gone to latlong.net for the coordinates of each of the locations I will be plotting on my graph. Here are the coordinates for Volochanka, Russia. And here are the coordinates for Wainwright in Alaska, USA. As you can see, these two are very close to the North Pole, and the distance between them is approximately 2.5 inches on my grid. The north-south distances from my last video were slightly less at 2.4 inches. I will now start the recording of east-west distances on the globe model by placing one end of the string at Volochanka. This is a small settlement in Russia situated north of the Arctic Circle. From there, we head directly east across the Bering Strait to a place in Alaska, USA that is almost the same distance north of the Arctic Circle as Volochanka. This place is Wainwright, which, as we can see, lies approximately 4.3 inches from Volochanka. This, according to the scale, tells us that the two locations are 2,150 miles apart. According to distancecalculator.net, they're actually 2,098 miles apart, giving us a discrepancy of 2,150 minus 2,098, or 52 miles. This is quite minor, being slightly more than 1/10 of an inch on the string. Next, I will measure the distance between Vancouver, Canada and Wasanipi, Canada. The distance has now become slightly larger yet, at approximately 2.6 inches on the flat Earth grid. Now we will take a look at how the same distance between Vancouver and Wasanipi measures out on the globe. Both are located just north of the 49th parallel in the northern hemisphere of the globe. Vancouver is a port city at the mouth of the mighty Fraser River, where it enters the Pacific Ocean on the west coast in the province of British Columbia. Wasanipi is a community situated south and slightly east of the Hudson Bay in the province of Quebec. Here the distance, as per the globe, is 4.3 times 500, which equals 2,150 miles, while distancecalculator.net places it at 2,084 miles, a difference of 66 miles. Our third pair of locations are San Diego, California and Jacksonville, Florida. Measuring the distance between these two cities introduces an error that cannot be ignored in the way that was possible with my first two measurements. Some might be tempted to say that those increasingly longer measurements were simply due to the fact that the grid was hand-drawn, or that it wasn't careful enough in plotting and measuring, but this dramatic difference here cannot easily be ignored. Now we have approximately 3.8 inches on the grid, instead of what we saw in the last video, which was a measurement of 2.4 inches on the same flat Earth grid. That was between all the north-south pairs of cities, even though they were almost exactly the same distances apart as San Diego and Jacksonville are on the flat Earth model. Now back to the globe. The end of the string sits beside the city of San Diego, California, a naval port and popular vacation destination on the west coast of America. From there, we go all the way across continental USA, skirting the northern tip of the Gulf of Mexico, and arrive at the city of Jacksonville, Florida, an eastern seaport bordering the Atlantic Ocean. The string shows us it is 4.3 inches on the globe from San Diego. This tells us a far different story than what we just saw happening with the flat Earth model between these same two cities. Measuring on the globe in the last video, the same north-south pairs that we used for the flat Earth model were seen to be either 4.2 or 4.3 inches apart. Here, between San Diego and Jacksonville, we measured 4.3 inches apart. This is as it should be if the globe accurately represents the shape of the Earth. So we could stop right here and declare the globe a winner, but we're not done yet. We still have a couple more pairs of cities further south to test and compare. If this is as it seems, then the next measurement should continue the trend to greater inaccuracy. So I will now measure between Malundu, Cameroon and Mogadishu, Somalia. Here we see the trend not only continuing, but becoming quite pronounced. Now the difference is astonishing, if we are expecting to find that the flat Earth is a true representation of the Earth. Measuring Malundu, Cameroon to Mogadishu, Somalia, produced 3.6 inches. Clearly an ever-increasing problem for the flat Earth model. So let's check and see whether or not the globe avoids this problem and continues to maintain its accuracy. Malundu is situated in the jungle of southeast Cameroon, a country that borders the Gulf of Guinea along the west coast of Africa. We will parallel the equator as we head eastwards until we get to the semi-arid port city of Mogadishu, Somalia. Measured on the string, we get 4.3 inches, which tells us that the globe has maintained its accuracy for east-west distances all the way from north of the Arctic Circle to the equator. Now we go as far south as possible for our purposes. This lands us in Australia. So here we see on the flat earth model that from Perth to Newcastle, the ruler shows 5.9 inches. This is more than 2 times the 2.4 inches given for the first pairs of cities I tested. And now we do our final test of the globe model to see how well it does this far south. Perth is situated on the west coast of the continent. Leaving Perth, we need to go all the way to the east coast to find a location far enough away to give us the distance I require. Even though this is as far south on the planet as I can get to find the necessary east-west distance across a landmass, these 2 cities are no further south of the equator than San Diego and Jacksonville are north of the equator. Here, in the humid subtropical climate of the east coast, is Newcastle, the final city we need to chart. I find on the string that the distance is 4.3 inches. This gives us a measured distance of 4.3 times 500, which equals 2,150 miles. According to distancecalculator.net, the actual distance is 2,088 miles, giving us a difference of 2,150 minus 2,088, which equals 62 miles. The greatest east-west discrepancy I could find on the globe is 69 miles. Being just over 1/10 of an inch on the string, 69 miles is insignificant. It pales in comparison to the 3,104 mile discrepancy found on the flat earth model. On this chart, we can plainly see that something went terribly wrong with the flat earth model. It started off just fine with the north-south measurements, but as soon as we started to map the east-west distances, we began to notice that the measurements were not quite what they should be. As we headed further south, we saw a greater and greater problem with the measurements, until in Australia, a family using a flat earth map and traveling from Perth to Newcastle would need to travel almost 2.5 times as far as Google Maps, the map in their glove box, or any GPS unit they might own would recommend. Anyone living in Australia, or anyone who has traveled across that country for that matter, please feel free to tell us in the comment section below if the globes in their classrooms or the Mercator maps on their walls using the same coordinate system I've been using here have messed up the distances so bad as to cut the distance of travel to less than half of what it should be. I know there are some Australian flat earthers out there. Maybe you can help me out here. Now, taking our final look at the figures for the globe model, we can see that all the measurements for the globe were accurate within reason for both north-south and east-west distances. My next video will examine in detail why this is so. I've designed an interesting experiment that anybody old enough to handle a knife safely can easily do themselves at home. Flat earthers are fond of telling people to believe their eyes rather than fall for deception that contradicts everyday observation and experience. For this reason, and many more, the experiment I will conduct in my next video is a must-see, bringing before your eyes a shape-shifting model of the Earth that shows why only a globe can properly represent our world. So if this is of interest to you, click on the subscribe button below and do the same for the notification bell to be notified when I post it online. Thanks for watching.